Welcome to Honors Geometry Lessons 6.4 and 6.5, where we prove that triangles are similar. Now we could use the definition of similar, where all the corresponding angles are congruent and all the corresponding sides are proportional, but we're going to come up with a couple of theorems and postulates here that will get the triangles similar using less parts. So let's go ahead and get at it right now. The angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Just that simple, just that easy. Go ahead and write that down, and pause while you write, and we'll get moving along after you get done writing. Alright, I think that was sufficient amount of time for me. I don't know about you, but here we've got a triangle, actually two triangles, and I definitely see one pair of angles that are congruent, those right angles, but wait, there's more. This vertical angle is congruent to that vertical angle, so these two triangles are similar using the angle-angle similarity postulate. So we are going to make first a similarity statement. We're going to put the first letters of the first triangle in alphabetical order. Triangle ABC is similar to triangle. Now let's get the angles in the correct corresponding order. Okay, A and X are both right angles, so X is the next angle. B is the non-vertical angle, that would be Y. So X, Y, C. Using the angle-angle similarity postulate. And what is that stinking scale factor? Find a pair of corresponding sides that are both numbers 16 to 24. So the scale factor is 16 to 24, and of course that reduces down to 2 to 3. So the scale factor of the two triangles is 2 to 3. And we could use that to find these two sides if I had actually asked you to do that. I'm not doing that right now. Your homework may ask you to do that, so you'll be using 2 to 3 equals X over this 24, and 2 to 3 equals Z, the longest side, the hypotenuse, over that hypotenuse. But I'm not asking you to do that. So that's one way to get triangles similar using the angle-angle similarity postulate. The second way we can get triangles similar is the side. How many sides did I say? Side similarity theorem. If three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. So we're going to look at this. Okay, what is the smallest side on that triangle? 3. What's the smallest side on the other triangle? 6. Does that equal the medium side on this triangle? 4. And the medium side on this triangle? 8. And does that equal the largest side on this triangle? 5 over the largest side of this triangle? 10. Well, what do you know? 1/2 equals 1/2 equals 1/2. Wow, now I'm actually wondering if you can even see that triangle. There, now I know you can see it. Sorry, my face might have been in the way blocking this corner. I always forget about that. So, when you write your three ratios, they all equal each other, so the corresponding sides are all proportional. So we need to write a similarity statement. Triangle DEF is similar to triangle. Let's get these in corresponding order. What corresponds with D? H. What corresponds with E? J. And what corresponds with F? G. And the reason is using the side similarity theorem. And what's that scale factor? Well, we've already figured that out actually. The scale factor is 1 to 2. And the third way to get triangles similar is using the side-angle side similarity theorem. If one angle of a triangle is congruent to an angle of another triangle, and the sides that include those angles are proportional, then the triangles are similar. So here we've got M congruent to U. Now let's see if the corresponding sides are proportional. Small side of the left triangle, small side on the right triangle, is that equal to 12 over 20. This reduces down to 3 over 5. This reduces down to 3 over 5. So the two triangles are similar. So our similarity statement is triangle MNO, alphabetical order on the first one, similar to triangle UTV, using the side angle side similarity theorem, and the scale factor is 3 to 5. Those are the three ways that you can get triangles similar to each other: the angle-angle similarity postulate, the side-side-side similarity theorem, and the side-angle-side similarity theorem. In the angle-angle similarity postulate, all you have to do is get two angles of one triangle congruent to two angles of another triangle, and the two triangles are similar. In the side-side-side similarity theorem, if you can show that three sides of one triangle are proportional to three sides of another triangle, then the two triangles are similar. And then with the side-angle-side similarity theorem, if we can find a pair of angles on two different triangles that are congruent, and the sides that surround those angles are proportional, then the triangles are congruent using side-angle-side similarity theorem. This does conclude lesson 6.4 and 6.5, proving triangles similar.